This podcast was recorded and provided by the National Association of Regional Councils. For more information about NARC, please visit narc.org.
Hello, everybody. This is Autumn Campbell, Director of Community Programs with the National Association of Regional Councils. Welcome to the first installment in our solar podcast series for 2013. These podcasts are brought to you as part of the U.S. Department of Energy's Sunshot Solar Outreach Partnership. Through this partnership, NARC is working with the International City and County Management Association, the American Planning Association, and ICLEI, Local Governments for Sustainability, to support local governments in increasing solar deployment in their communities nationwide. Today I'm joined by Jason Halpern, founder and CEO, and Patrick Murphy, founder and president at Gridless Power. They are joining me today to talk about an exciting alternative use for alternative energy. Emergency uses of solar technology, for example, after extreme weather events or other natural disasters. Together, Jason and Patrick founded Gridless Power, which is deploying solar technology in non-traditional formats when conventional power sources may be scarce or unavailable. On the Gridless team, Jason oversees technical development, product strategy, intellectual property, testing and validation, and manufacturing. He received degrees from UPenn in mechanical engineering and management with a master's in integrated product design. Patrick has been the self-described evangelizer of this alternative energy concept. Over the past 5 years, he's inspired investors and government officials to share in that vision. He oversees the Gridless company strategy, including product sales, marketing, and strategic management. He attended NYU and received a degree in policy economics. Thank you for joining us today, Jason and Patrick. So jumping right in, first of all, could you tell us a little bit about how first responders manage their power needs at present?
Sure. At an organizational level, first responders tend to use large generators that are mounted on trucks or other vehicles for critical operations. These generators, they tend to power electronics associated with a command center or a command tent, and that includes communication to the outside world, radios, and some degree of critical lighting. But on an individual level, there isn't really an organizational solution. They've been managing power the same way for disaster response really since the 70s and 80s, before a lot of small-scale electronics became integral to disaster response. So you've got a lot of first responders that are bringing car chargers and other ad hoc solutions to try to charge their technology on sites. So this will include even cell phone charging, which they don't have a great solution for right now.
So when first responders plan for disaster operations, how long do they need to assume that they'll be without standard electricity?
Well, it tends to vary between agencies, but we found that the standard for first responders tends to be around 72 hours. So 72 hours of operations, communications, and like we said, that basic lighting they need to have on the trucks with them. And then after that, they'll have supply chains that they've hopefully been able to set up to support the operations.
You mentioned generators are the key component of power for disaster relief. Could you explain how generators are used, sized, and how it is determined what load to place on them?
Sure thing. So, yeah, as Pat mentioned, generators are an important part, actually the critical part of how power is managed on disaster relief sites at the moment. So generators are used to power critical loads, command and control, electronics, computers, limited lighting, and oftentimes even HVAC systems associated with different command assets or trailers. They are sized to support a base load and then whatever surge load it takes to start those HVAC systems or pumps or other surge loading devices they happen to have on them at a given time. What this creates is a situation where a generator is very much oversized to support the base load. The base load is just determined by looking at the power consumption of all the devices that you have, making some reasonable expectations of how much you'll have on at a given time. So like X number of computers and this many radios and things like that. And then on top of that, the generators have to be able to support those surge loads, which means that you have a generator designed to support, let's say, 20 kilowatts total between base and surge loads, but it's actually only supporting, let's say, 10 kilowatts or even, say, 5 kilowatts of load on a normal basis. And just to simplify that, If a generator isn't supporting close to what it's rated at, it's actually running very inefficiently. It's running, it could be doing something called wet stacking, which damages the generator, and is all in all just a non-optimal solution. Unfortunately, if you just have a generator, it's about as good as you can do. You size the generator to support as much load as you think you're going to have, and you kind of deal with the consequences. And you even sometimes have to build a buffer in so that if more equipment is added to the system, you can support it. So there's usually some sort of factor in there, factor of safety in there as well on the normal capacity. And the higher the generator rating is compared to your base load, the worse the situation is. So it's a tricky balance, and generators alone don't do a great job of really addressing that core problem.
Got it. So how does solar and battery technology play a role in these operations?
So right now it's the generator, and like I said, the generator is an imperfect solution. It runs lower than it's supposed to. It doesn't run efficiently. And what solar and battery technology can do is they can solve that problem, and they can solve it very effectively. They can essentially take this imperfect solution of the generator, and then by adding in batteries and solar, you create a perfect hybrid solution that takes advantage of the benefits of solar and the benefits of the generator to combine to form a solution that doesn't have that level of inefficiency in it. And you can save 50% of your fuel, you can save 50% of your generator runtime, and it really creates a smarter system that's able to take advantage of, like I said, the benefits of the different technologies. In addition, the solar and battery technology can support loads that a traditional generator just couldn't support. You don't want to run small loads off of a 20 kilowatt generator, and you don't want that many small generators floating around disaster sites. So distributing solar and battery technology in a smaller way gives you the ability to do things like cell phone charging all over the place without having to worry about putting down a large temporary infrastructure. So solar and battery technology help in the generator scenario, and they also allow different types of smaller power distribution to happen in a very lightweight, very fast, and easy way.
Great. Well, we've seen several different portable solar devices, some attached to a trailer, some a little larger, and some smaller. Could you tell us about some of the options out there for using solar?
Yeah, so there are several solutions out there. The ones you mentioned, there are solar trailers where you can pull a trailer onto the site. It usually has a number of panels on the top and a large lead-acid battery bank. On the opposite side of the spectrum, there are small consumer electronics devices that do things like charging cell phones and charging laptops. One point of caution on the consumer products is if you are advising first responders on potentially getting into this kind of technology, make sure they look at the ratings on that technology and they understand whether or not it can live up to the harsh conditions in a disaster site. And it's not just sort of a thing that you're supposed to put into a backpack and bring out on a sunny day that can really take the kind of abuse that's going to get in a real disaster scenario. So you've got solar trailers, consumer electronics. There are a couple different companies making sort of medium-sized solar generators in the middle, things that you can forklift onto site as opposed to trail onto site. And then on the high end or the large end, you can basically bring a shipping container full of solar panels and lay down an entire temporary installation. Now, one thing to be aware of with all of these solar solutions is if anyone is saying replace your generators with solar, that is a risky proposition because solar has limitations that the generators balance out. So if you have just a solar system, you need to oversize that system. It needs to be very, very large to support the loads in the event that the weather doesn't go your way. There's a cloudy day, and all of a sudden, you can't have your command and control tents going out. So if people are trying to sell pure solar solutions for these large power problems, just a word of caution is to look into ways that they could potentially do a hybrid solution or to find somebody who could do a hybrid solution because it tends to mitigate the risks that the solar brings to the table and the risks that the generator brings to the table in a really powerful way. So the solutions that are the best are the ones that are able to combine both technologies, and just be aware that there are uses for just solar and just batteries, especially on the small side. But as you scale up, it gets a little bit trickier, and you want to find the solutions that really help you mitigate the risk of both the solar and the generator and create a better system as a result.
That makes a lot of sense. So whatever product size you use and whatever is right for your operation, the concept itself seems simple enough. You get a panel, an inverter, and a battery, and make it mobile. I'm sure it's not, though. Could you tell us about some of the complexities behind making this work, such as control software, communications, GPS technology?
Sure. So if you were a hobbyist with a decent background in sort of electrical systems and electrical engineering, you could certainly put together a system that delivered power off of, let's say, a lead-acid battery through an inverter that you could pick up on Amazon and a small panel that you could also pick up on Amazon.com or out at Walmart or wherever. It's possible, and depending on your level of skill, you could hit a certain level of sophistication. But there's a lot of subtleties and nuance in combining all the different technologies and making the right choices, the right battery type, the right inverter, making everything work really well together. And that's the kind of thing that we live for at Gridless, and our competitors live for at their other companies, is figuring out those things and solving those challenges to deliver the best solar product at the end of the day. So my advice would be, that's one option, and if your first responders are incredibly savvy, they certainly can. But you're going to end up with a much more efficient, much more ruggedized, and much more complete solution if you go out and actually buy the combinations of them. And there are some things that a hobbyist level system just couldn't do unless you're a particularly skilled hobbyist or actually just an electrical engineer and have a lot of time on your hands. Hybridization is a challenge. There aren't off-the-shelf solutions that allow that to happen on a sort of part-by-part basis. And the things that you mentioned, control software, communications, and GPS technology, are another level of complexity above sort of the typical panel inverter and battery system. And those would allow first responders to really understand where their units are, what they're doing, what they're powering, and provide fleet management. And it's those things that are really big value adds, just in terms of making the technology work in these settings, that are harder to get if you're putting the system together yourself. So we recommend, we live for putting together these solutions, and we want to provide first responders, and our competitors want to provide first responders with the power that they need to do their job. And we want to do our job, which is figuring out how to provide that power.
Right, right. And, given your experience in the field, so to speak, could you tell us a little bit about the reactions from first responders who are using this technology for the first time?
Yeah, we have a pretty great example of that from very recently, because of, we are located, Gridless is located in the New York, New Jersey region, and we just got hit by a big hurricane, Hurricane Sandy. And during that time, we were able to kind of pull all of our equipment out of the lab and try to get as much of it deployed as possible, because New Jersey got hit so hard, and so many areas were knocked out, and there were so many first responders on the ground that had power needs. And really, it was a matter of, we called police stations around the state, particularly in Seaside Heights, which is one of the hardest hit areas in Toms River, and we said, hey, we've got this technology, and a lot of these guys hadn't heard of us. And so they said, well, let us think about this. We're not really letting civilians onto these disaster areas right now. Let us get back to you. And we actually ended up getting a police escort onto a few of these hard-hit locations on the first day after the hurricane, put down some portable solar systems, some portable battery systems to assist the first responders. And the reaction was very, very positive. We actually got well, you guys are going to need to come back from now on. You realize that, right? So we were not just down there for a day or two. We actually ended up going down in different areas in New Jersey every day for 2 or 3 weeks after the hurricane. And then after that, we actually were able to partner with some of the local police benevolence association down in Seaside Heights and Toms River, as I mentioned. And they were able to distribute some of the technology into some of the hardest hit locations for us. And we only came up every once in a while after that for the next few weeks to assist them, make sure that there were no problems. So these guys, I think it goes back to Jason's question. One of the reasons why you want to have a professionally designed product is because it's important to make something that is very, very easy to use. So anybody can look at the product and understand, this is where I plug it in, this is how I network things together. Just making it very, very easy for these guys to adapt the technology. And power is important. They understand it, and they understand when their cell phones are dead and they can't call their families. So they've really embraced a lot of the technology as we've gotten it out there in a really big way, which has been nice.
Great. So in addition to the emergency response departments and the individuals who are serving on the ground and using your product directly, have you worked with local or regional governments before? If so, how? And also would ask, who are your typical clients that you would approach about the solution?
We have, like I mentioned, we partnered with police benevolence associations. The company was founded from the Edison Administration Clean Energy R&D Fund out of college. We were able to receive that grant, and that was a partnership with the New Jersey Board of Public Utilities. So we partnered with local police, local firefighters, Police Benevolence Association, and the Board of Public Utilities. In terms of people who are really embracing the technology, I would say that agriculture is a big one. The Board of Agriculture, the Department of Agriculture in New Jersey has been big embracing the technology and talking about, we've gotten around to talk about how it can really help out farmers in remote areas. I'd say really, our name is Gridless, so there are opportunities wherever there is no grid or wherever the grid is unreliable. So whether it's telecommunications, disaster response, agriculture where farms aren't always hooked up to the grid, remote mining, there are all these opportunities where, you don't think about when you're right next to the grid in your house and you can plug into the wall, but there are a lot of areas where power is really critical and not necessarily as convenient. And the real pie-in-the-sky opportunity here, I think everybody probably is thinking of when they think about the different kinds of portable solar technology, is areas around the world that don't have a power grid. So there are many, many, many people, around 2 million people in the world that don't have reliable access to electricity. And just getting them that base level of electricity to do lighting. Lighting up the first few homes in a village drastically increases the standard of living and is the most valuable energy to get out there. So really we see the big pie-in-the-sky opportunity here beyond these local opportunities of agriculture, disaster response, are getting out to gridless areas of the world and supplying them with critical electricity to increase their standard of living and to kind of make the world a better place. So that's kind of our big goal here with the company, is to get out to these villages and help providing reliable electricity to villages.
That's great. Anything else that we should know or that you would like to tell us about this technology and about your work in this industry?
Well, I'd say that it's really critical that disaster response and a lot of areas of power management are able to innovate and move forward past what we've been doing for long periods of time. So it's generators are great, and generators have been around for a long time. And I think that the best way to get these kind of new technologies out there is, instead of saying, let's go all solar or all wind or all renewable, let's try to figure out how to realistically get these products out into the world. And that's why one of our big focuses is on hybridization, because we're not going to replace a disaster site. We're not going to have FEMA going out there right now with a 100% solar solution and not having any generators, because that would be crazy. But at the same time, there are technologies out there that make the way that power management is right now crazy too, because just having a generator, as we found out in New Jersey after Hurricane Sandy, is supply lines. You can't always get the fuel. You can't always get the fuel out of the ground. And there's a lot of logistical difficulties with supporting the kind of infrastructure that we're used to supporting. So there's new technologies out there that are actually practical and reliable, and we really are working on developing them and getting them out into the world.
Well, I think that's a great place to conclude. I just want to thank you both so much, Jason and Patrick. It's been great talking to you today. To learn more about how regional planning organizations and governments can use solar technology in disaster preparedness plans, visit Gridless Power online at gridless.com.
Thank you for listening. For more information about NARC, please visit narc.org.
Thank you for listening. This podcast was brought to you by the Sunshot Solar Outreach Partnership, funded by the U.S. Department of Energy to increase the use and integration of solar energy in communities across the U.S. For more information on the Sunshot Solar Outreach Partnership, visit our website at www.solaroutreach.org or find us on ICMA's Knowledge Network at www.icma.org/solar.